In this unit, we are going to look at trigonometry. In section 6.1, we are going to work on converting between degrees, radians, and revolutions. So let's start with drawing angles and a few definitions. So there is a thing called a ray. A ray is essentially a line that has an arrow at the end. That's a ray. It starts someplace and then goes on forever. When we draw an angle, we are drawing two connecting rays. They connect at the vertex, and that's where our angle is. We have the initial side where the angle starts, and the terminal side, which is where the angle ends. A radian is a measure of the central angle of a circle, such that the length of the arc between the initial side and the terminal side is equal to the radius of the circle. The radian measure of a circle is the ratio of the length of the arc subtended by the angle to the radius of the circle. In the circle of radius 1, the radian measure corresponds to the length of the arc. So what does that mean? So we have a circle. It's a terrible circle, but we're going to pretend that's a circle. It has a radius. Let's say that radius is 1. Let's say that we have an angle inside the circle. Now this part of the circle here, this rounded part, kind of looks like the crust on a piece of pie. That is the arc. The arc of the circle is measured by the angle and the length of the radius. When the length of the radius is 1, the arc is the same as the radian degree measured in the circle. That's why radians can be very useful. They can be helpful when trying to determine the length of an arc. We're not going to worry about determining lengths of arcs in this course. I just wanted to show you what a radian was and why it's important to learn them. So, degrees, radians, and revolutions. One revolution is one trip around the circle. We have a circle, go all the way around, that is one revolution. That is the same thing as going 360 degrees around the circle. It was also the same thing as 2 pi radians. Why does 2 pi radians make sense? Well, we're assuming the radius is 1. What is the circumference of a circle? It is 2 pi r. If r is 1, then the circumference of the circle is simply 2 pi. So let's look at problem 1, converting between degrees and radians. We have all these degrees. We want to convert them to radians. Let's start with 0 degrees. 0 degrees is 0 revolutions. And it's also 0 radians. At 30 degrees, how far did we travel around the circle? Well, the circle is 360 degrees. We traveled 30 degrees. That is 1/12 of the circle, so that is 1/12 of a revolution. How about radians? Well, if the circle is 2 pi radians, we can do a simple conversion. We're converting from 30 degrees to radians. So in 30 degrees, we want the degrees on the bottom, right? And we want the radians on top. So let's compute that out. Let's keep this in terms of pi. Let's not get rid of our pi. Who wants to get rid of their pi anyway, right? 30 times 2 divided by 360. So if we wanted to keep that as a fraction, that would be 60 pi over 360. 60 goes into 60 and 360, so it'll be pi over 6. Pi over 6 radians. How about 45 degrees? So we have 45 degrees. How far is that around the circle? Well, we can do 45, 90, 35, 80. So that's 4 times. 4 times the other way. That's going to be 1/8 of a revolution. What if we wanted to straight up convert to revolutions? How would we do that? Well, let's look. 1 revolution is 360 degrees. We're in degrees. We want to convert to revolutions. So we're going to have 360 degrees on the bottom, 1 revolution on top. We end up with 45 over 360. That reduces down to 1/8. Just to prove you, 360 divided by 45 gives us a denominator of 8. If we wanted to convert it from revolutions into radians, 1/8 of a revolution times how many revolutions versus pi. So there are 2 pi radians for 1 revolution. So we want 2 pi radians for 1 revolution. So we'll multiply the top, multiply the bottom. We're going to keep this in terms of pi. We get pi over 4. I'm just going to do this first quadrant and then we can move on. So how about 60 degrees? Let's straight up convert 60 degrees to revolutions. We've got degrees on the bottom, 1 revolution on top, equals 60 over 360, which is 1/6. So 60 degrees is 1/6 of a revolution. How about converting 60 degrees into radians? Again, we want degrees on the bottom. 2 pi radians on top. We're going to keep this in terms of pi, so we'll have 120 pi over 360. 120 goes into 360, or 360 goes into 120 3 times, so we're going to have pi over 3 radians. One more, let's do 90 degrees. 90 degrees, we can kind of see that that's 1/4 of the way around the circle, but let's do this mathematically. $360 degrees on the bottom. We get 90 over 360, which is 1/4. So it's 1/4 of a revolution. We were right. How about converting it into radians? 2 pi radians over 360 degrees. We get 180 pi over 360. That reduces down to pi over 2. If you want to, you can go ahead and finish completing the circle, after which we can start filling in the blanks. We're going to convert all of these things. So we have 1/3 of a revolution. How can we convert that into radians? So 1/3 of a rev times 1 revolution on the bottom. We have 2 pi radians on top. That is going to give us 2 pi over 3. How about degrees? 1/3 of a revolution times 360 degrees in 1 revolution gives us 360 divided by 3 is 120 degrees. How about 3/4 of a revolution? 3/4 times 2 pi for 1 revolution gives us 2 times 3 is 6 divided by 4 will give us 3/2, 3 pi over 2. How about 3/4 converted to degrees? Multiply it by 360 for 1 revolution. Let's see. 360 times 3 divided by 4 equals 270 degrees. Let's see how this matches up with the above so far. So we're traveling 1/3 of the way around the circle. We're at 120 degrees. Does that look like about 1/3 of the circle? Well, it is. So that definitely matches up. How about 3/4? Traveling 3/4 of the way around the circle, we always travel counterclockwise. And yes, that does give us 270 degrees. Now let's convert from radians to revolutions and degrees. So let's look at this. Pi over 6 radians times 1 revolution is 2 pi radians. Pi cancels out, and we get 1/12. Let's see if that matches up. And yes, it does. Look at that. About pi over 6, convert it to degrees. Times, we want it in degrees, so degrees is on top, over 2 pi. Our pi's are going to cancel out. 6 will turn this into 60. The 2 will turn it into 30, so we end up with 30 degrees. Does this match up with what we had up here? Yes, it does. Now let's convert 3 radians. So there's no pi in this radian, so we might get kind of a funky number. So 3 radians times 1 revolution over 2 pi radians. Our answer is going to be 3 over 2 pi. How about degrees? Now we don't usually keep pi in our degrees, so we are actually going to calculate that one out this time. So we have 3 radians times 360 degrees over 2 pi equals, so 3 times 360 divided by 2 divided by pi gives us about 171.9 degrees. So when we see radians without pi attached to it, we get some pretty crazy numbers. Let's look at negative 3 pi over 4. Degrees can be negative. That just means that we're moving clockwise instead of counterclockwise. 1 rev over 2 pi radians. Pi is going to cancel out, and we'll get negative 3/8 of a revolution. How about converting it to degrees? Negative 3 pi over 4 times, we need degrees on top because that's what we're converting to. Radians on the bottom. Pi is going to cancel out. So 3 times 360 divided by 2. 540 degrees. I just want to make sure I didn't type that in wrong. Oh, because it's 4. It's happening because my marks keep disappearing for some reason. Okay, that's better. 3 times 360 equals, divided by 8, negative 135 degrees. These are all degrees, even though my degree symbols disappear. All right, now we're going to convert from degrees to radians and revolutions. So 15 degrees times 2 pi, because we're converting to radians, 2 pi radians over 360 degrees. So let's see what we get. We'll have 30 over 360. That'll give us pi over 6. Wait a minute, not pi over 6. 30 over 360. Pi over 12. Now let's convert to revolutions. 15 degrees times 1 revolution is 360 degrees. So 15 over 360, we get 1/24 of a revolution. That kind of makes sense because 30 degrees was 1/12 of a revolution. This is half of that, so it's 1/24. 126 degrees, we'll convert that into radians. So 126, 26 times 2 divided by 360. 252 over 360 is 0.07, so that is 7/10. So 7 pi over 10. Now let's convert it to revolutions. 126 degrees times 1 revolution for 360 degrees. 126 over 360 equals 0.35. That's 35 over 100. 35 over 100, both could be divisible by 5. So that'd be 7/20 of a revolution. Notice a pattern with the revolutions and the radians. The revolution is 1/2 of what the radian is without the pi. So take off the pi, add another or multiply by another 2 in the denominator, and you'll get revolution. So that's a little shortcut if you're feeling comfortable enough to use it. So next we're going to be talking about sine, cosine, and tangent. So I don't have anything for you to practice on here. If you want to, like I said, you can complete the unit circle. You can Google to see the solution to that as well if you want to check your answer.